In this video, I want to talk about how we can graph some exponential growth and decay functions. So exponential functions have the form y equals a times b to the x power, where we have a couple stipulations. A can't be 0, and the base b is a positive real number other than 1. So we have a couple options. If a is greater than 0 and b is greater than 1, then our equation y equals a times b to the x is an exponential growth function. So that's one of our options. We could have exponential growth. And b is called the growth factor. The parent function is y equals b to the x. Our other option that we're going to see in just a minute is going to be an exponential decay function, and we'll talk about what our value for b is going to be when we get to that in just a second. So let's focus on exponential growth to start off. So we have f of x equals b to the x, where b is greater than 1. And so here's what our graph would look like. Notice how we are increasing from left to right. Notice a couple points on our graph. We have 0, 1, so we have our y-intercept at 0, 1, and our first point is going to be 1, b. So we can always figure out where we have other points by making a table of values, plugging those values in for x, evaluating that, and that'll give us some coordinates. So just a couple things to note about an exponential function. Notice on the left it says the x-axis is an asymptote of the graph. And so what is an asymptote? It's just a line that a graph approaches more and more closely, but it's not going to cross. So when we look at this portion of the graph down here at the bottom left, that graph is getting closer and closer and closer to the x-axis, but it's never going to go below it, meaning we don't have any negative y values as part of our range. That's why we see right here the range of our function would be y is greater than 0, because our function is always going to stay above that x-axis. Now it is going to go left forever and it is going to go up and to the right forever. That's why our domain would be all real numbers. And then the last thing I want to talk about, the graph rises from left to right, and like we said earlier, that passes through the points 0, 1, and 1b. So that's what our exponential growth function would look like, increasing from left to right. Okay, now let's talk about exponential decay. Exponential decay now is where our number for b is between 0 and 1, so it's some kind of fraction. So now b is called our decay factor, whereas earlier, when an exponential growth, we called it the growth factor. Okay, so now still the x-axis is an asymptote of the graph, but now notice our graph is falling from left to right on this exponential curve. So we still have these points 0, 1, and 1b, but now we are falling from left to right. And so notice our asymptote over here, right? Our graph or our function is going to continually approach the x-axis, getting closer and closer and closer forever, but never touching it or crossing it. So once again, our range is still numbers that are greater than 0. And our domain is still all real numbers because our graph is going to approach left and right forever. Okay, so let's look at a couple examples. We're going to do one where we have exponential growth on number 1 and one where we have exponential decay on number 2. So just to make it a little bit easier for us, I've made a table of values. Now these might not be the only x values that we use, but it's a good place to get us started. So for number 1, we have y equals 3 to the x power. So I'm just going to plug in, first of all, when x is 0. Now this is y. Our y-intercept is going to be just 1. Now our y-intercept is going to be 1 unless we have another value a that we're multiplying here, but that's a different type of exponential function that we're not looking at in this video. In this video, we're just looking at where a is just equal to 1. And so in this case, this would be y equals 3 to the 0 power, and we know anything to the 0 power is 1. So we would have a point at 0, 1. Now for our b value here is 3, and on both of those examples we saw previously, we say we have a point at 1, b. And the reason that is because whenever we have a base raised to the power of 1, it is just itself. Okay, so we'll have a point at 1, 3. Now 3 squared would be 9, and 3 to the third would be 27. So we can fit 2, 9 on here, but as you can see, we don't have enough room to put 3, 27 on this graph, so we just know it's there, right? Now, what would happen if we extended this graph to the left? So if look at my pattern here, we're multiplying 3, right? 1 times 3, 3 times 3, 9 times 3. So if we think about going back to the left, we're thinking like, okay, let's divide by 3. So I know if x was -1, then I would have a point at 1/3, right? And then we would get closer and closer and closer, 1/3, 1/9, 1/27, right? We're just getting closer and closer to 0, but actually never touching the x-axis because it's an asymptote or crossing it. So now what we can do is draw our curve through our points as best we can. And we just kind of want to make it extend across this x-axis. Okay, just kind of like right here, not crossing it, but just getting a little bit closer as we get further to the left. Okay, so that's what y equals 3 to the x would look like. All right, number 2, y equals 1/4 to the x power. So now we should expect this one to be decreasing, something like that. And so once again, now let's plug in some of our values. So we know, once again, anything to the 0 power is 1. So that's why we have 0, 1. 1/4 to the first power would just be itself. So we have a point at 1, 1/4. And notice we're just going to keep getting smaller, right? And so think about what's happening. We are multiplying by 1/4, or maybe you could think we're dividing by 4 as we increase. And so to go back the other way, we would be multiplying by 4. So if I have a point when x is -1, then I should have a point at 4. And then when x is -2, we would have a point at 16, which obviously we can't fit on our graph. But this gives us our general shape that we need to graph. Okay, so we're drawing our curve here. And we're going to finish it off with pretty much, it looks like a horizontal segment, but we know it does in fact get a little bit closer to that x-axis as it increases to the right. So not entirely horizontal, but that's what our graph would look like. Okay, and so that is how you can graph some exponential growth and decay functions.